Okay, so the first lesson that we are learning for Unit 3, which is right triangle trigonometry. That is the goal. By the end of this unit, you will know how to use all of the trig functions to find missing angles or sides in a triangle. Well, one of the most important lessons that you have to learn about triangles is the Pythagorean theorem. I know that you're familiar with this either from the 8th grade or the ninth grade because we did this in Algebra 1. So this should be a review. If it is not a review, that's okay. It is a very easy topic to learn and to master. So our first lesson for Unit 3 will be Pythagorean's theorem. You will probably use the Pythagorean theorem on 50% of the problems that you're given on your CDA. Okay? Notice that it says the Pythagorean theorem is a tool that we can use for right triangle problems only. Well, right triangle means that we have to see the 90-degree angle. So one of the three angles in your triangles have to be a right angle or 90 degrees. Okay, that's very important. You cannot use this if you look at the angles inside of your triangle and none of them measure 90 degrees. You have to see either the little box or that they've given you the measurement as 90 degrees. One of your angles must be 90 degrees. So that leaves 90 degrees left for me to split between the other two angles. All right. So when do you need to use Pythagorean's theorem? And this is like very important for this whole unit. You're going to use Pythagorean's theorem whenever you know the lengths of two of your sides. So if I go back and I look at the triangle that I drew over here, if they give me that the length of one of my sides is 10, and I know they're talking about a side length because they'll put the 10 on the outside, that means this side's measurement is 10. And let's say they give me the measurement of this side is 12. Okay? They ask me to find the length of the third side. So we'll call this x. Okay? So this is what I mean when I say when you know the lengths of two sides. They have clearly given me the length of this side of the triangle and the bottom side of the triangle. You will only be dealing with triangles in this entire unit. So if you know two side lengths and you need to find the third one, then you can use Pythagorean's theorem. Once again, you must see a 90-degree angle in order to use Pythagorean's theorem. Okay? So let's see. What is Pythagorean's theorem? I figured as soon as you saw this formula, you'd remember, oh yeah, I remember Pythagorean's theorem. So we have to have the 90-degree angle, okay? And A and B in this right triangle are considered legs, okay? A and B, when you use them in the formula, it doesn't matter if you put B first and then A second. It doesn't matter, just so long as both of the leg pieces are on the left side of your equation when you write this. C is very important, and he has a different name than the rest of them. We don't call these legs. For C, we call him the hypotenuse. And an easy way to determine which side is the hypotenuse, remember we used this when we did hypotenuse leg and we were proving two triangles congruent. The hypotenuse is always directly across from your right angle. So if you follow your right angle and draw a line from it, the side that is the diagonal side is always your C. Okay? Notice A is straight up, B is straight across, C is diagonal. It is very important that you know how to pick out which one is C and put him on the correct side. If you mix up C and you put them on the side where A and B is, you mess up the whole Pythagorean's theorem. So this theorem says, if I know the length of A and I square it plus the length of B squared, that has to equal to the third side of the triangle. So you can use Pythagorean's theorem to determine if a triangle is a right triangle. Because remember, this only works with a right triangle. So an easy one to try would be a triangle that has a measurement of 3, 4, and 5. So some of your homework problems may ask you to determine if this is a right triangle. So all I have to do is take the sides and plug them in. So my A side is 4. So right here where I see A, I would put the number 4 and I put a square on it. Plus, my B side is 3. So 3 and squaring. That has to equal C. And remember, C is the diagonal side every single time, which is 5 squared. When I square A, I get the number 16. When I square 3, I get the number 9. And if we add 16 plus 9, we get 25. So I get 25 on this side. Now I have to make sure that I get 25 on this side. Well, 5 squared is the same thing as 5 times 5. So that is also 25. So I could say, yes, this is a right triangle. And I've just confirmed that by plugging in A, B, and C, the 3 measurements that they gave me, and making sure that A squared plus B squared does indeed equal C squared. Okay? That would probably be the most basic type of problem if I asked you to determine if it is a right triangle. I did not give you examples on that because I figured that was a little too elementary. But if you see some of them on your homework, I have went over how you would check to see or determine if it is a right triangle. Now, if you plug in those numbers and you get 36 on one side and you get 25 on the other side, that's not equal, and that would mean that it's not a right triangle. Alright, so how do we use Pythagorean's theorem to solve for a missing side? So remember up here we said we would know 2 sides and we would need to find the third side. Now they can put the third side wherever they want to. It could be on the hypotenuse or it could be a leg. So I'm going to show you how you would solve for those 2 instances. And it does change, okay? So this is our first example. Notice that we have a triangle that looks like a right triangle. I have a measurement or a number outside the triangle of 20. I have a measurement over here of 15. And I have a measurement of x that we don't know. So obviously I'm solving for x. Now it is important that you're able to identify the hypotenuse. So in this example, they didn't show us the right angle, but we can tell that this angle would be the angle that would have to be the right angle. There is no other angle that makes the corner of a square. Okay? So that means x is the hypotenuse. Because the hypotenuse is always the diagonal side of your triangle. Now they didn't identify which one was A and B, and that's not important. All I know is that 15 and 20 are the legs of this triangle. They must get plugged in for the leg side. Remember, A and B are legs, and C is the hypotenuse. So as long as we plug them in on the correct side, everything will work out great. So I'm just going to say that 15 is A and that 20 is B, and that means X is C. So let's plug it in. Plugging in for A here, 15 is A. So I would have 15 squared plus B is 20. So where I see B in the formula, I'm going to put a 20 there, which makes this 20 squared equals, and the hypotenuse is C, but in this example they say that C is X, so I'll just say this is X squared. Now if you did not want to change your variable for C, you just wanted to write it as C squared, that's fine, no problem with that. So now we have an equation, we just need to solve it. So using your calculator, you can type in the entire left side of the problem. So I would type in 15, hit the x squared button, plus 20, hit the x squared button again, and I get 625. It is important that you're hitting the x squared button, okay, and not the number 2. Because if you just put 15 and then put a 2 next to it, it's going to multiply 15 times 2, which would give you 30. That's a much smaller number, okay? Or you could type in the number 15, and you can use the little up caret key and then the number 2, and that would make 2 an exponent, okay? Plus, okay, 20, up caret key, and the number 2. So that gives me 625. Now, they asked for me to find x, not x squared. So we have to get rid of this exponent of 2. And if you remember, I told you that we could get rid of an exponent by taking the square root. The square root and a square are opposites of each other, so they will cancel each other out. So to get rid of the exponent of 2, we take the square root of x squared, and we'll take the square root of 625, okay? This is probably the step that most people forget, so please don't fall victim. Make sure that you take the square root of both sides, okay? So taking the square root of x and x squared gives me x times x, which means it's a perfect square because I get 1x that comes out. Okay? Now, on the left-hand side, you want to put this in your calculator. So remember, we're hitting second, which is your blue button, x squared. Hit your second button, hit your x squared button, and then type in the number that's under the radical. Close the parentheses, and we get our answer, which is 25. So, when you present your answer, the last thing that you do when you're using the hypotenuse, the Pythagorean theorem, is you need to look at your answers, look at how the numbers look in your problem. This is going to help you determine if you have to round. Now, my numbers were whole numbers, so when I look at my answer, I know it makes sense for my answer to be a whole number. So now we just present our answer. So, x equals 25. Or the hypotenuse is 25 units. Okay? And that is how we use Pythagorean's theorem. So the most important part to remember is that the hypotenuse is c, and it goes by itself on one side. Okay? So now we'll look at example number 2. Now, when we look at this triangle, I can obviously see this would be the right angle over here. So 10 is the hypotenuse. So this time, I'm not solving for c. I have a number for c. 10 has to go for the variable c because it's the diagonal side, and the diagonal side is always c. So that means over here, a is 6 and b is x. So let's plug in all the numbers where they go. A is 6 squared plus b is x. So x squared equals c, the hypotenuse, is 10. 10 squared. So notice if you look at the step that we're at now and the step that we looked at in the previous problem, we're going to have to solve this a little differently because in our previous problem, the numbers that were on the left-hand side were all numbers. Well, that doesn't quite work out that way on this problem. But we're still going to go about solving it like we would solve any equation. Okay? So, what should we do first? Well, I see numbers that are squares, so that tells me I probably can go ahead and do these. 6 squared is the same thing as 6 times 6, which is 36. Plus, well, I can't do anything with x squared, so I'm just going to leave him the same as he was. But I can work with this 10 squared. That is the same thing as 10 times 10, which is 100. Alright, remember when you're solving an equation, the goal is to get the variable to be by itself. So x has to stay on this side. You never move the variable. We want to move all the numbers to the other side. And since 36 is on the same side as x, we're going to move 36 because we want x to be by itself. So remember, you can't just pick 36 up and put them on the other side of the equation. You have to use either addition or subtraction, and you're using the opposite of what you see. So since 36 is positive, we subtract 36 on both sides. Well, 36 minus 36 eliminates, and I get x squared by itself on that side. On the other side, we do 100 minus 36, which gives me 64. Okay, we're almost there. Who remembers how we get rid of the square that is on my x? Correct. All I need to do is take the square root of both sides to get my answer. So the square root of x squared and the square root of 64. Well, the square root of x squared, the square and the square root cancel each other out, so I just get x. And on this side, we get plus or minus 8, but it will just be 8. Okay? So we just found the value of x. So one leg is 8 units. And the other leg is 6 units. And we found the value of the missing leg. I hope this helps. This video will also be available on my website, sylviaanderson.weebly.com. Okay, remember I told you that website needs to be your best friend. So that is just 2 examples, 2 beginning examples of how to use the Pythagorean theorem, which is the majority of your work that you will have today. The second video will go over application problems so that you're ready for any type of problem that I give you using Pythagorean theorem. Thank you.